So in this demo now we look at behind the scenes of Gen AI model deployments and how to manage multiple model deployments. So in AI Essentials, which is the software that runs on private cloud AI, there are models curated from NVIDIA. So for example, in this particular release, you can see that there are various models that are curated and persisted from NVIDIA as part of the software release. And this is something that will continue as the software release progresses. But the Gen AI landscape is evolving rapidly, and we need a flexible way to be able to bring different models and deploy them and manage them. So that is offered by this service called HPE MLIS. So this is machine learning inference service, and it uses Kubeflow Caser as its engine, but it does have a lot of HPE IP. So one of the fundamental things that we can do in MLIS is to create different registries. So this is one example of a Hugging Face registry that allows me to import Hugging Face models. I can also create a registry for NVIDIA NGC that will allow me to import any additional names that I need, NVIDIA names that I need. And I also have ability to register standard machine learning registries. So for example, this is a registry based on S3, and it points to the area where MLflow, which is also part of private cloud AI, stores its model artifact. So this is another way of connecting to a local registry within the private cloud AI. So this registry concept provides a very flexible way for connecting to various model sources. Either they are models persisted locally, or they may be models from well-known registries such as Hugging Face or NGC, NVIDIA NGC. So now the next step is to use those registries and define some models. So you can see that this is one traditional machine learning model, and it's based on artifact tracked by MLflow, which is also part of private cloud AI. So that is a model that is picked up from the artifact in the S3 object bucket, which is internal to private cloud AI, and then it is a CPU only model. As you can see, there's no GPU that is required by this model, and this is the kind of models that you can also manage. But more interesting use case is for Gen AI. So for example, this is one example of how NVIDIA NIM can be deployed. So this is a NIM, and again it uses internally a Triton and TensorRT LLM as the runtime. And in this case, that name is being picked up from the one that we have curated within this particular AI Essentials, right? So that's where it's being picked up, and obviously it has its GPU among the resources that is assigned. Now, the third example is where there's a model that uses the same underlying model, which is Llama 3.1 instruct, 8B instruct, but it is using a completely different runtime. So it is using the VLLM runtime, which has become extremely popular in recent times. And of course, to make the VLLM runtime work, there are some environment variables and some engine parameters. So all those are defined within this particular model definition, right? Now, one of the interesting things that happens within HPE machine learning inference service is that as I create different versions of the model, they get maintained within the system, and it's possible for me to deploy multiple versions of the models at the same time. Or of course, I can deploy multiple models. So it's a highly flexible system that gives a lot of different ways to manage all sorts of models. So now these are the deployments. So these are the models that are actually running and can be used for inference. So so you can see that there's an endpoint that is exposed for each of the model that is live, that is running, and that endpoint is the one that is used by an API for the API calls. So you can see that there's a VLLM running, and the version that it's running, as well as the URL endpoint that it has. And of course, it's a secure model, so there will be a token that needs to be used to interact with this model. So that is also there. And of course, any other parameters if required, as well as any kind of model deployment alerts or messages that we can see. And then, of course, the resources that are there, which include the GPU resources. One additional element that we can do is we can define auto scaling, and we can define multiple replicas of the model. So currently I'm just using one instance, but this auto scaling will get automatically handled behind the exact same model deployment URL. So it's all transparent, and it doesn't need any effort from the user except specifying how many instances we need, and the scaling policy. So let's just also look at the name. So this is the NVIDIA name, and it also has its own URL, and the same things will apply, such as the token, etc. So now I think what we want to do is to test some API calls to these model endpoints. And what I want to show you is how easy it is to change between the models at the backend, right? And still your client can keep making the same API. So let's just simulate a very simple API example here. So so one of the first things I need to do is to set my model API endpoint. So I'm just gonna do that here. Okay, so I define the API endpoint, and as you can see, I'm defining the API endpoint to the NVIDIA name version of the model. So it's been defined there, and of course, I need to also use the security token. So I will also use that so that I can make secure calls to this API. So that is also defined. Now I think what I need to do is to this is where the tokens are, and I picked it up from the system earlier, when it was created. So now I think what I'm going to do is just run one API so that I can check the model that is running at this endpoint. So let's just try that. So this is the API that allows me to query the v1/models endpoint, which tells me what model is running, what version of the model is running, what type of model. So you can see that for my NVIDIA NIM endpoint, I'm running a Llama 3.1 8B instruct model. And that's what I have deployed. So I know that I'm able to now programmatically connect to that API endpoint and access it. So now the next thing will be to run an inference example. So I'm just gonna do the API call for inference, model inference. So but in the meantime, I'm just gonna export the model also as a environment variable, because that is required in some API calls. So I do that, and now I'm going to do the API endpoint. So if you see the API endpoint here, It's a standard open AI compatible API that is there, and basically I'm using the model API endpoint, the security token, as well as I'm basically going to stream the response, and I'm going to only generate 15 tokens because I don't want to generate too many. It's just an example. So if I do that, it's streaming, so you can see that it does generate token by token response. So every response is a JSON structure, and it has a token plus other info. So you can see that it was streaming tokens back to me, and you can see the tokens within the response as I'm highlighting here. So yes, I mean, I can use a streaming API. I can generate a response to my prompt against this NVIDIA NIM model. So that's great. So now I'll just do a non-streaming one, and just to make sure that that also works. Okay, so now I have pasted the non-streaming one, and I'm just going to run it, and I just want to do of course you can see that it did generate a proper response for me. I'm just gonna do one that looks pretty, so it's easier to read. So you can see that yes, now I can see what was the response, and I can, so that's the response that I got, and I can also see what tokens it generated. So there's some token statistics also included in the response, etc. Right? So this allows me to use the API endpoint with the model. Now, let's just say I want to transparently change the model to VLLM, right? I want to still run Llama 3.18b instruct, but I want to use VLLM now instead of NVIDIA NIM. So again, the process is very simple. I take the new model endpoint, and I will of course have a token for that, which also I would have taken. So I take this. So let's just define the new API endpoint. So I just change my API endpoint, which is now to VLLM version, and then I add my endpoint token. There we go. So and then I think what I need to do is again to run the API to check the model running at this location. So let me just quickly try that. And you can see that yes, I mean, it is still the Meta Llama 3.18b instruct running. So yeah, I mean, that's great. So I was able to seamlessly change my model to point to a different model without basically changing anything from the client side. I'm still using the exact same method, exact same API calls from client perspective. The only thing I change is the token and the API endpoint that is there, right? Let me again generate some response. This time maybe I will just skip the streaming part. Maybe I will just generate a completion kind of a response. So let's just do that. Okay, so as you can see that I have streaming off and 15 tokens, and I also have a different prompt this time. So all of that is set up. So let's just try this. So this is again the exact same API call, if you recall, that I did with the NVIDIA NIM before, and you can see that that exact same API call still works even though I changed the model on the backend. So I'm now using a completely different model, and I'm still, from a client perspective, there's no change. I'm still using the exact same API, still doing the exact same usage of the model. and so it's fully transparent to me as a client, right, for an inference use case. So this is a extremely powerful capability that we got within HPE's private cloud AI, and it's a very flexible, very versatile capability, HPE machine learning inference service running on top of Kubeflow Kserve, and that just gives us a really great way to manage models in a very flexible, transparent way. So that's what I wanted to cover in this demo. Thank you.